Sorry, I can share the link of this thing in the chat. Can you check?
Yes, sure.
Okay, sir, I'll doing it.
Yeah, we have already seen it. Okay, so I just let me confirm that the same question or it is different.
Sir, I have the link is there on chat, sir.
Okay.
If you open it,
Just yeah. Okay, let me share my screen, then we can easily
yes,
reach out that. You can tell that. Okay, just a minute.
yes, sir.
Okay.
Are you
Hope
able to
my
open the
screen
link,
is.
sir?
Yeah, I
Yeah.
have opened.
Yes,
Okay.
sir. The first set,
Okay, which question?
page number 54.
54.
Yes, sir. In this, the fourth option, the domain of the function g of f of x, it's supposed to be closed interval -2 to infinity.
-2 to infinity.
Yeah, but it's supposed to be closed interval, and given it was not closed interval, I didn't mark it.
Is that I don't know. Is that all of you are getting that the same, or it should be closed or open?
Sir, it should
At
be
2,
closed.
it should be closed.
At -2, sir. Because
Okay,
at
at -2,
-2,
the
f of
domain
x is
of
defined.
g of f. So
Yeah.
g of f. So here is okay. Here is -2 is acceptable. Here is also acceptable. Okay.
Yes, sir.
So yeah, it would be, yes, it should be close.
Also, sir, there's one more question.
Mm-hmm.
Page number 49.
49. Okay.
So question number 64. Sir, this was very confusing because the options, none of the options fit. Because the
Mm-hmm.
question has specifically asked where in its domain it is discontinuous. Now, our domain doesn't include values 1 and 2. So, if you check it, our domain comes out to be real number minus set of 1 and 2.
In
So
its domain, okay.
generally when we are asked a question, for instance, of log x, if is log x continuous in its domain, then we consider the domain 0 to infinity, for which log x is continuous. Just
Yes,
like that, in this function as well, in the domain real number minus 1 2, it is continuous, sir. But uh, like if it was not specifically stated, like is the function continuous in its domain, then we could have said at x equal to 1 and 2 it is not continuous, because it is not defined at those points. But in this question they have said domain, and sir, the definition of domain is the values for which the function is defined, right, sir?
Yes.
So none of the options are fitting, and I didn't mark any of it. So in the answer key, it has come out like this.
Mm-hmm.
So there is an
Okay.
I
error
have
in the
marked,
question.
excuse me, sir.
Yes.
Like I have marked this question, this option only, and after finding f of x, because it is written clearly that the function f of x in its domain, and it is discontinuous only at the points x equal to 1 and x equal to 2. So this is only for the confusion, I think, this domain part where it is written, because it it is clearly in its domain, and we have to check that it is discontinuous only at the points at x equal to 1 and x equal to 2.
Sir, this is
So
why
that's
I
what I
asked the
think.
case of log x. For instance, log x, if you ask, then it is continuous in its domain, right? But if
Mm.
you ask, is log x continuous, then we can say at x equal to 0, where log x is not defined, it is not continuous. But if a question asks, is it in its domain continuous, then we have to consider the domain only, sir.
Yeah. This would be. This is the one question I know that, but you are saying the another one, which is at 49. Yeah, we'll check that both.
49 and 54. Page
71,
54.
sir.
Sorry.
Page 54, question number 71.
Yeah, 71. It is something.
The last option. It should be
Yes.
closed interval -2 to infinity. So these two questions, sir.
Okay.
Sir, so basically the correct answer for 71 should be just g of x should be log of x plus 3.
Yes.
Yeah, that is correct. And yeah, that should be the correct. Only one option should be correct.
Yes, the rest of the three are incorrect actually.
Yes.
Sir,
Yes.
but what about this question 64, which was in page 49? If so, none of the options are correct, then will everybody get the mark?
Yes. I this time I am unable to say, but yeah, it will be like we'll consider it, and all of you will be notified with the announcement. I will announce in the announcement regarding this pitch, or what we are thinking with these two questions. We'll let you know. Okay. This time I'm not currently tell you that
Okay,
what
sir.
will be what we can do,
But
but
whatever
now
I
later we
pointed
can.
out is correct, na, sir?
Yes, that's fine. Yeah,
Okay,
it is
sir.
correct.
Thank you.
Yeah, it should be close and there, and that should be. I've seen from the feedback I've seen there that question have some issue, but this is the one
Yes.
question which I also have.
Yes, sir. Yes, sir. Okay,
And
sir. Thank you for checking.
I will check the whatever the 49 pages were there. That is already none of the option is correct.
Yes, sir.
This should be, if we give here -2, then this is valid and this is also valid. Okay. We'll let you know. Okay. With the announcement, I will send an announcement in the
Yes, sir.
portal
Sir,
also,
given
and
the
with the
ambiguity, a lot of people kind of selected multiple options. So it should be, my request is to kind of grant marks for all the cases. Because
Okay.
this concept of discontinuity in the domain was not taught to us. So given all this, I think, it will be better if everyone will get marks for this question.
Okay, let's see. Okay.
Yes, sir.
Yeah,
Thank you, sir.
we'll
Thank you
concern
for
it.
considering, sir.
Yeah.
Okay, thank you.
Okay.
And sir, just one more thing. I've just posted a question in the chat. Can you please have a look at that question as well?
This problem. Okay. Let me open it. This problem.
Yes, sir. This is the one.
Is this a problem of the quiz?
No, sir. Actually, it was in a previous year question for the end term.
Okay. So it is asking the largest means exactly domain. What is going to be the largest interval which can be the domain of the function? Just asking the domain of the function, and if we need to find if we found, then what is the value of a plus b? So what is the issue? Are you able to solve this problem?
Yes, sir. But sir, the problem is that I'm getting a different answer from what was given in the answer key. In the answer key, the answer was given as 5, that the value of a plus b should be equal to 5.
Okay, let's quickly do it. So this is we have, so this log base 2, and this is x square minus 5x plus 8 is there. So that means the first thing, this should be greater than 0. Right?
Yes,
So
sir.
this is one thing. So if it is greater than 0, then this is going to be 5 we need to add, so that we will get here minus 5. So how we can do the fraction? What is going to be the fraction? Yeah, it could be written as 4 cross 2. You are not getting in the integer. You are not able to get in the integer form. The roots are.
Yes, sir. So that's the problem with the roots.
So I
Okay.
think this one, the discriminant is
Sir, actually,
less
the
than
discriminant is less than 0.
less
So
than 0.
ideally, no
B
root
square
should
minus
exist.
4ac is there. So B square is 25 minus 4 into A is not, it is not less than, this is 8, no? This is okay. Oh,
Yes, sir.
Yes, sir.
So the
So,
discriminant
so
is negative.
so this is 25 minus 32, so less than 0. So there is no real root.
yes, sir, exactly.
So to
But
get,
that
okay,
is
just
fine, no, sir. It just means that we cannot have a value for which the inside
yes,
log
yes,
can be 0. So
yes,
this
yes,
is
yes. So
not.
yeah, that's how I'm going. So that's how I was to saying. So this is, we just need to, for values for which this is going to be positive, no?
Yes,
We
sir.
don't want the root, we just want to know where it is positive. So this is never going to be either by this way 2x, okay, minus 5,
Yes,
and
sir.
this is the derivative of this one, is this one 2x minus 5,
Yes,
and
sir.
so this is the derivative, so it is increasing. So what is going to be here, let's draw there is no real root. And what is the symmetric? That is, vertex minus b by 2a, which is here. Minus b is 5 upon 2, which is 2.5. So that means it will be like this, right?
Yes, sir.
At 2.5, here is suppose 2.5 is there. This is 2.5. So it is always positive. It will be never negative.
Yes,
For
sir.
all,
So for or r, it will be positive, right?
so for all r, it is going to be positive. So it is defined. This log is defined for all x. Now we need to find log. This should be strictly greater than 0, right?
Yes,
This
sir.
should happen. This should be strictly greater than 0. That means our log 2 is log 2 with this one should less than 1. Then it will be, and when this will be less than 1, that means 2 power, this means x square minus 5x plus 8 should be what?
Less than 2.
Less than 2. So when it is less than 2, this is output, no? So, or maybe x square minus 5x, this is going to be plus 6 is less than 0. This we want, right? So now this is 2 into 3. So the x minus 2 and x minus 3 it is.
Okay, sir. So that's 3 plus 2 and it would give 5.
Yes.
Okay, sir. Okay. Thank you, sir.
Okay, let's move ahead and let's discuss the graph theory we have.
Sir, can you
Okay.
please just scroll up once? I need to take an image of the solution.
Okay.
Yes, sir, done. Thank you.
Sir, like for the discontinuity question, what I mentioned before, I got so confused about this concept that I like, because I checked the limits for both the cases, limit extending to 1 and limit extending to 2, left and right limit, because we were only able to go to values as close as possible to 1 and 2, right? But not to values other than that. So when I found the limit, I found that extending to 1 is both, like from the left and right, it goes to the same value. Whereas for when we consider the case of 2, it goes to minus infinity and infinity. So I sort of interpreted it as maybe that is like this idea of discontinuity and marked 2 and came.
Sir,
So
that
my
is
point
the
is that there's a lot of
exactly same
ambiguity.
problem.
So there's a lot of ambiguity in that question. So that is why I requested to give marks for like all the options.
Okay.
Sir, just to confirm, the basic idea about discontinuity is just we can check discontinuity only on points for which the function is defined, right? Like for
Yes, the
which we
function
have.
is defined, and so there is, if we are checking in for that problem, we have the function 1 upon x minus 1, right? So this is the
Yes,
function
sir.
we have. This is fx. And what is f of this one? This is going to be
1 by x minus 1 minus 1.
X minus 1 by 2 minus x.
So this is
Yeah,
1
we get
upon 1 minus x minus 1, and this is x minus 1.
yeah, because we have removed the problematic areas of 1 and 2, so we can manipulate the equation to be of this form, this rational equation form. X minus 1 by
Yes.
2 minus x.
So this is not
So
2 minus, so this has become plus. Okay, this is 2 minus x.
2 minus x, yes, sir. So here, given, like I said, this is where we were not taught the idea of discontinuity. So I thought maybe we should check the limit for this and see if something returns from that. So when I took the limit for 1, as you can see, the left and the right limit becomes 0.
So here is the problem is the first need to find the domain. So domain of this one is what?
Real
1
number
at
minus
1 it is
1,
not
2.
defined. So already
At
1
1
is
and
not
2.
in the domain. Okay, 1
At
is not
1,
in the domain, so it will not come in the domain of f of composition.
x,
That's
yes.
some composition.
Yes, sir.
And also we don't want to.
Yes,
So
sir.
whatever we don't want to here, if you substitute here 2, then there is a issue. Like if we
Yeah, it is not defined.
if we are substituting 2, then we'll not get we'll get output. So it is going to be what? So this is going to be 1. So what value of this is going to be 2? So this is 2 here. This is x.
So 1 by x minus 1 cannot be 1. So like 1 by x minus, the equation should be.
Sorry.
Sir. Yes, sir. Like for f of x, 1 by x minus 1 cannot also be equal to 1. So that is how we get x equal to 2. You kind of took 1 by x minus 1 equal to 2. I am saying it should be 1 by x minus 1 equal to 1, because that is when this 1 by
sorry 1 by
x minus 1 equal to 1.
Okay.
In that case, it won't be defined. So that case, x equal to 2, it will come.
So in that case, it is going to be x is equal to 2.
Yeah, so x equal to 1 and 2, it
No,
won't be
we
defined.
don't want x is equal to 2. We want such that the output means here is that we don't want this output, this image should not equal to 2, right?
No, sir,
No,
that should
sorry,
not
this
equal to
this
1.
is not equal to 1.
Yeah.
This should
That is
not
what I was
equal
saying.
to 1. Yes,
Yeah,
here
that
is
is what I
not.
was saying, sir. Yeah.
This should not equal to 1. Sorry, not it is
Yeah.
not 2. This should not equal to 1. So this,
Yeah,
if
so
it is
x
1,
cannot
then
be equal to 2.
so that means here this is x minus 1 is equal to 1 and x is equal to 2.
Yeah, so x equal to 1 and 2, it is not possible. Matlab, our domain is not.
Yeah, so
our
domain
is
of
a
this
real
one
number.
is
Yeah.
1
R by
and 2.
the set 1, 2. Yes, sir. Yes, sir. So I was saying that given we were not taught this and none of the options were matching, I thought we are now supposed to take the limit and see if something returns from that. So when I took the limit, for instance, of x minus 1 by 2 minus x, our problematic numbers are 1 and 2, right? So I first took left limit and right limit of 1. So there I was seeing that it was going to 0. And for the left limit and right limit of 2, it was going to minus infinity and positive infinity. So I thought that is what this discontinuity is about. So that is how I interpreted the question. So my basic point is that given we were not taught this and all, and given the question was
Excuse me,
framed this way, it was open for multiple interpretations.
excuse me, sir.
Yes, yes.
So like for the function to be continuous, sir, there has to be 3 conditions. First condition
Yeah,
is
that's
to
the
be like
only
the,
without checking or without going to the limit. First need to do we need first thing that
to
it
check
should be
for
the
the
function
for that
output.
particular point.
Means at
Yeah,
once the
the
function should be defined. Means defined means a value should be there, no? Then the left
Yeah,
limit,
yes,
right limit, and function values.
yes, sir.
All three should be equal.
So, sir,
So,
at
but
1
it
and
is
2,
not at
the
one. We have
function is not
already we
continuous.
are not able to get the value. Similarly, at at 2 he is whatever at 2 we are unable to get the value. So
Yes,
because
sir.
It
of
is
that,
not continuous.
Yes,
it is
sir.
not.
No, sir, I think he was meaning like when we check continuity, we check left limit, right limit, and the function's value also at that point. Like
Yes.
both need to equal, both three of it needs to equal, right? That is only when we
Yeah.
say it is continuous.
Mhm.
But in this case, we can never go check the case of 1 and 2. F of 1 and F of 2, we can never check. So the only options that we can have is to check the limits. So that is what
Like
I
why
said.
we cannot check? Why we cannot check for I'm just asking why we cannot check
It is
for
not
like
defined.
the point
At x
f of
equal to
1 or
1
f
and
of
2,
2.
f of x is not defined, right? So how can we check the value of f of 1 and f of
So
2? It is not defined.
yeah, so
Then it would be discontinued.
Yeah, but they have
so it
asked
is
in the
not
domain of
defined, then it
the
is
function.
discontinuous. That is
Yeah, but they have asked in the domain of the function where it is
they are telling
discontinuous.
that f of f, they are just telling that f of f is in the domain and check for the discontinuity at x equal to 1 and 2. That is what I think.
No. They have asked like where in its domain
Like
it is discontinuous.
question is very clear, I think.
Okay, so don't worry. Let me check. Okay, we'll with our team. We will check and then let you know. Okay, I've just listened that till now I didn't see. But I will see it with the team, and whatever the
Yes, sir.
final will be, we'll let you know with the announcement. Okay.
Yes,
So
sir.
don't
Please give
worry.
marks for
Let's
all
continue with the
options, sir.
session of the graph theory. No need to be discuss more about it. We already get that. Okay,
Yes.
there is an issue in these two problem. Okay.
Yes, sir. Yes, sir. Thank you, sir.
So
Yes,
don't
sir.
worry.
Fine, sir.
Okay, let's move to the our session. So this session is for I have just wrote this session. This will be an open session, and also I just kept as a solve with us. So let's one remain concept is that DAG is there. Last time we discussed BFS and DFS also. Breadth first search and depth first search we have discussed. Now only written the next concept is directed acyclic graph. DAG, which is generally called DAG. So what is first thing is DAG? Our graph should be directed. First, now we need to know, or the first thing is that our what is DAG? So what is this DAG is there? First thing, what is the directed graph? So if it is, last time we already discussed that. We have already discussed that what is the directed graph, or maybe see if graph is given and suppose this is two airports, and or even let's say this is Delhi, this is Chennai, and this is Mumbai, and the connecting flight is like this, and the direction is given like this only. Okay, if it is like this, suppose this is Delhi, this is Chennai, and this is Mumbai. So to reach Chennai to Mumbai, there are two ways. Like here, this direction is given that the flights, this arrow and this edge is representing that okay, there is a direct flight, or there is a path between these two airports. So that means here from Chennai directly we can reach to Mumbai, and similarly from Delhi also we can reach to Mumbai. But if we want to take a flight from Mumbai to some other place, then there is no information is given from this graph. We want to go with the graph, and this is the only route of flight. So there is, if you want to move from Mumbai to Chennai or Delhi, so there is no route to go. Okay, so this graph is a directed graph, and but is this graph is directed? So this graph is directed, but it is acyclic. So what is the acyclic means? This graph should not contain any cycle. So as here we can see that it is actually, see, this cycle means what? If it is between these two and this, and if it is the arrow, if suppose this arrow is this side, then there is a cycle is happening, this one, and then this, back to the same origin. Cycle means from different path you are able to reach with the same vertex. If it is such thing is there, then it will become a cyclic graph. So as here there is but previously it were like this. So in this case, this is actually a DAG. There is no cycle in this graph. So this is the meaning of DAG, and there is a, we have already. Let me go to the one problem. From problem, we can reach out to that. Let me take this one. So we have this graph. Suppose we have this graph, and so whenever we have a DAG, okay, whenever we have a DAG, then there is two different topic we are going to study. That there is you need to sort the vertices, and another thing is find the longest path. So longest path, which is of week 11 content, we'll see later. And here we will see only the topological sorting. So what is the topological sorting? Means suppose these are the courses of these are the courses like course E, then F. These are the courses sorry, these are the subjects. Even we can say these are the subjects in a course. And once we finish, we want to finish the course, then we have to at least complete all these subjects, or all these are topics. Okay, so if you want to complete or we want to take the subject H, then we have to first, or anyhow we have to complete the course, because this is a dependency. So to reach or to do the subject H, we have to first complete G, and also we have to complete the course, sorry, subject C, and this subject these two subjects at least we have to complete. So this is the meaning that here is, you can say, this is a foundational course, that this is anyhow, or core course it is. You have to first do that, and after doing this course or this subject E, then you are able to do the subject A and similarly F, and then B also, or not B means after completing E. So this is a dependency, mean to say this is showing the dependency on the subject. Without completing, if you want to go to the course or subject G, then without completing the subject B and C, you cannot complete the course or subject G. This is the dependency mean to it is showing. So whenever such type of a problem is there, so in which order or what are the courses or how we will take the courses, that's the meaning, are we are sorting, or that's the meaning are sorting the vertices, that is called topological sorting. And this is one thing, and here is one thing, that in degree and out degree thing is there. So here is this edge. If you take this edge, am I audible to all of you?
Yes, sir.
Yes, sir.
Okay.
Audible.
Yes, sir. Yes,
Okay.
sir.
So if you take this edge, in this edge, this is outgoing edge for this vertex, but the same edge is incoming edge for this vertex A. So, and similarly this edge is again the outgoing edge for E, but incoming edge for F. So this is the meaning of incoming and outgoing edges. Now in degree and out degree is the word is there. So here is in degree means incoming, number of incoming edges. How many edges are actually, so how many incoming edges with that vertex is there, then that is called in degree of the that vertex. And how many outgoing edges are there, so how many outgoing edges are there for that vertex is called out degree. So there are 2 degree, in degree and out degree in the directed graph. Okay, so now here we can see the outgoing edges are 2 for the vertex E. Okay, this vertex outgoing edges is 2 and incoming edges is, there is no incoming edge. So here is in degree. So in degree of here we can write in degree is 0. There is no incoming edge. Outgoing, so an outgoing incoming degree and outgoing incoming edges and outgoing edges in degree and out degree. So out degree is 2. So but we only concerned about the in degrees. Okay, here is only we just need to know in degrees. So here is for the vertex C, in degree is 0. And this is one property of a directed acyclic graph, that whenever you have a directed acyclic graph, means that the graph should be directed and it should be acyclic. If it is acyclic, then there is a property that in that graph there is a vertex which have in degree 0. It is always true. So we have in the lecture, you can see the proof also from the lecture. Okay, but this is one property that of a DAG, that there should be a vertex where the in degree is 0, and there will be a vertex where the out degree is 0. Like for this vertex, D, the out degree is, see that the out degree is, the every vertex or every edges are actually in incoming edges. There is no outgoing edge. So out degree is here 0 and in degree is here 3. So in a DAG there is a property that there should be a vertex which have in degree is 0, and there will be a vertex where the out degree is 0 in a DAG. So this is one example here. And now how will so we want to find an order. So suppose this is one real life problem, that these are the courses we have and we want to complete this course without if you want to complete or we want to do the course C So we have to this. So there is no dependency on C. So see that. So first thing, or even complete the course C, or we want to complete the course B, we have to complete the at least E and F. Without that, we cannot complete the course B. Similarly, other. So in which order we will try to find, or in which order we need to proceed so that we are able to complete the all courses. That's the here problem. So first thing, let's count the in degree and out degree. So for this vertex, in degree is 0. For this vertex, in degree is 1. For this vertex, in degree is 3. For this vertex, in degree is 3. For this vertex, in degree is 0. For this vertex, in degree is 3. For this vertex, in degree is 2. And for this vertex, in degree is 2. Okay. Now, so that algorithm, whatever we have the algorithm, how we can proceed to find order, which is called topological sorting. Okay. And so what we can do, we will take here a vertex which have 0 degree. From there we can, so there is, if there is no dependency, we can do the course. So either we can do the course from C, or we can do the course, first course, this E, we can start. In degrees, both have vertices have in degrees 0. So let's take here, let's keep out this order. Okay, this E is there. Okay. So Solvitus is actually, that's why it is actually Solvitus. I don't want to do the Solvitus. The reason is, it is already available in this portal here. So there are 2 sessions. I will suggest you these 2 sessions are actually important. This one session is open session, and this is a Solvitus session. It is, that's why we are keeping or continuing with this 2. Okay. So these 2 sessions are actually good, and that's why it is recorded, and it is.
In fact, I would suggest, sir. In fact, I would suggest it is better people go through this first, because I see these are much more better than the other lectures.
Yes. That's why we are actually keeping these 2 sessions and continuing with this. This is actually continuing. So, and it is actually taken by
Shubham sir. The problem is when we go to this each week, right? So for our first tendency is to cover lecture 1, lecture 2, lecture 3, and then come to the later parts, right? So by the
Yes.
time we come here, we would have spent a lot of time. And when we
Yes.
spend a lot of time, and when we go to the assignments or practical assignments or graded assignments, we might not be able to solve. But if we look into the Solve with Us and open sessions, there is more experience that is being talked about here, and more practical approach that is being talked.
Yes.
So
Yes.
in every week lectures, these are much more better than the original lectures. I don't know when these original lectures were done. I don't think they have been updated.
No, it is not older. It is not, these sessions are sorry, the lectures are not older, but yeah, sessions are actually good. Here is whatever. So actually, what is the issue? No, that the section, these sessions are actually first done with already. If you have, so see what is the process to go with the per week content. So first things that at least once you have to watch the all lectures, so that you know the topics and bit knowledge about that. These things are very necessary for each week. You have to go through with the all lectures and know what are the topics taught in the lecture. First thing, at least these are, and also bit knowledge of the topic. If it is not clear, or once you watch the all lectures, after watching once you got that, that's fine. If not, you can watch the second time or thrice, okay, 3 times, 4 times. But you can come to the session also, and there we can discuss the topic. So these
No, sir,
sessions
I'll
are
tell you
actually
one example. I'll tell you. Okay.
Hmm.
If I had not watched this solve with session or open session, some of the points which are being told here, I don't find in the lectures. For example, the maximum independent set plus the minimal vertex cover, it's equal to the total vertices. Okay, this point is not there in the lecture. Like that, multiple things are there.
So actually, those things are actually skipped. Or here, that's the thing. Here, just need to think that okay, maximum independent and minimum vertex cover both are actually give the number of vertices. So this is one part that this is these are the tricks you have to think your own. But in the sessions, while doing the question, it is very obvious our student already asked, or there are some problem in the session already taken with those things that okay, just go to or solve that problem and you'll get that okay, this property is holding for all graphs. So that's why it is not in the lecture, but it is not a kind of you have not seen that in the lecture. Yeah, these are the tricks you have to when you will do more practice or your own, you will solve the problem, you'll get these two things or whatever you are saying that in independent set and minimum vertex cover. So this is one thing. Yeah, the suggestion is if you have watched the lecture, then it will be easier to whatever we are discussing here, that will be easy to catch up that. So these two sessions are actually, that's why it is continuing here, and all of you can go through with these two sessions.
The lectures are giving a basic input about the content. Okay.
Yes, basic input.
Yeah, and if you are watching these open sessions or whatever discussions we are having now, this is where the experience is coming, Shubham sir. Okay.
Yes.
So you might, I mean, it's my feeling, you might give a little bit low priority to the lectures because you don't need to spend 5 to 6 hours and all. You can quickly browse through. The reason being, if you're going through the lectures of 10, let's say, assume this is 10 lectures of half an hour each, 5 hours gone. And if you are taking notes, at least 3 hours is required. 8 hours you will spend.
Yes.
But all this is covered in 2.5 hours in these two lectures with more practical examples.
Yes,
so the priority for the open session should be much more than the lectures. This we are not aware. Now only we are getting to understand.
So it's totally up to you. Yeah, that's one thing. Yes, if it is actually the graph 3, that's why these two sessions are actually continuing. See that everything is written there in that format, and it is how we will proceed. The algorithm is also there. What is adjacency matrix? So this everything is are in this two sessions. So that's why we are keeping these two sessions. And also
this. Anyway, it's a suggestion. It's a suggestion from my side or your side. I think that is what I found to be best, including all the chapters or all the lectures.
For all lectures,
weeks, all weeks.
For other weeks also.
All weeks.
Okay. Yeah. Okay. Okay. The last two session I took also with I don't know. I maybe will continue with. On the calculus, I am thinking maybe I will keep some sessions which I have taken also. Calculus portion. We have discussed slowly with the limits. Sorry, sequences limit. Okay, let's see that. So and yeah, similarly in the week 11 also there are two sessions. Okay, and it is in the portal. My suggestion is also whenever, or even you can directly go with sessions or watching the lecture. It's totally depend on the person that or a student how he want to go. My suggestion is first go the lecture. Without going lectures, you cannot see the topics. What are the topics have taught there? Okay.
So week 11 sessions are
Sir,
tomorrow.
can you please explain the Riemann sum once? I have tried to do it multiple times, but it's still a little confusing.
Okay, just a minute. Okay, let me finish that what I'm saying. Okay, so these two sessions are also there. Okay, the solve with us. That's why there is no mean to keep solve with us session. We will keep open session for week 11 also. Similarly, whatever we are doing for week 10. Okay. So 2 sessions also there. And there is one big, of week 11, there is a Floyd-Warshall algorithm. If you want to go with these topics, so this session is very, very much helpful. Srikanth have taken this session and slowly, very slowly teaching that how this Floyd-Warshall algorithm will done, or how to find a SP7, SP3, SP4. Very slowly everything is doing. And he spent it, 2 hours on this Floyd-Warshall algorithm, how to proceed. And he also give the trick directly how to jump. If you want, you can directly go to these sessions are actually, you can go to these sessions to know the algorithms, Floyd-Warshall algorithm, and how to solve that problem. It is a kind of tutorial.
Srikanth Venkatesh is not taking any lectures now, is it?
No, he's an instructor and some other courses now. I think if you are doing Stat 1 or maybe Stat 2, then you will get, he will be there.
Okay.
Okay, so these 2 sessions are actually a kind of tutorial. Okay, we can go with that.
So like without going through the lectures, like not some of the lectures, like
you cannot.
with
Yeah,
only
that's the
going
thing. That's the I'm saying. Without going to the lecture, you cannot understand even the tutorials. So first thing that you have to bit knowledge about the topic from the lectures. You have to. You don't want to make a note. That's totally up to you. But at least see the lectures, know the topic, know the definitions, know the, because each time whenever instructor is something is telling, he will refer to, I hope you have seen this, I hope you have seen from the lecture. He will refer to the lecture as a book. Lectures are, you can think as a book, and he is saying to be at least watch, or sorry, at least read out that book, means you at least watch that lectures. Once you know that, then here we can easily understand the tutorials.
it is easy, like if we watch these 2 like then we are comfortable with solving the questions.
Yes, if these 2 sessions, similarly in week 7 whatever 10 we have, and similarly here for week 11, if these 2 sessions means 4 sessions, then you have a proper, you will be get a proper knowledge of whatever the week 10 and 10, 11 and content have.
Okay. Thanks, sir.
About those topics you will have a proper knowledge. Topics are not tough here, only just need to understand. Okay? Topics are not tough in the graph theory here. Okay, let's move ahead and okay, so we are discussing about this one. So topological sorting is algorithm. The algorithm is that just take the in degree, or first take that vertex which have in degrees 0, so and list out that. So this is, I'm just listing here. Okay, so this is one, and if you want, you can note the in degrees also. So like in degree of is 0. Now once you have this one, let's now okay, so after sorting, let's remove that. Okay, so if you remove this, then if you remove this vertex, okay, so now the in degree will be removed for the other vertices. Okay, so now in degree of this one of A, it will be become now 2. Let's update that in degrees, and in degree of this one will come now again 2, and in degree of this one will come now from 1, it will be 0. This is the process we will take to sort out or sorting the vertices. Now we have updated one, this. Now again this is a DAG. Now this is again a DAG, and start with the which have 0 in degree. Okay, so we can do with the C or we can do with F. So let's take F now. Okay. So here is the next one is F. And let's remove now here this one. So I just remove that. So remove that. Removing this vertex means you have to remove that edge, or removing means I have already sorted here. So I just remove that. Now let's update the in degrees of after removing whatever we have removed here. So here is this two edges, outgoing edges were with the vertex. So here is now update will be, it will become 1. Here it will become 2. Now these two are done. Now this is a DAG. Now each time once you remove that vertex, it will become a DAG, and we'll proceed with that vertex which have 0 in degree. So again, now we have a, this is a DAG and it have a 0 in degree with vertex here C. Now we'll list out C. So once we have the next is, we'll proceed with the C. So let's remove that now. Okay. If we remove this one, then we will remove with the outgoing edges also. So it have 4 outgoing edges. We have removed all. Now once we remove, we'll do the update in degree of after removing the out degrees. So here it will become what? So it will become 0 now. Here the update will be what? Here is in degree become, previously it were 2, now it will be 1. Here it will be 1 now because it was previously 2, now it will come 1, and here it will be 1. So once we remove, okay, once you remove that, you will get a vertex which have, so once you remove, you will always get a DAG. Means if you are getting a DAG, means surely it have a vertex which have in degree 0. So as here we are doing here, see that it is once we are removing that vertex, means we are sorting here. We are sorting it here, and once we and removing the outgoing edges related with that vertex, and we are always getting a DAG which have the in degrees 0. Some there is a vertex which have in degrees 0. Like here, we again got a vertex B which have in degrees 0. Okay, so now this is time to remove that. Means let's sort out this vertex B here. Okay, and now we'll start removing. Once we remove this vertex, the outgoing edges will be removed. Okay, so let's remove that. So we removed here, so outgoing edges is removed with this one, and these two outgoing edges were there with vertex B. Now let's update the in degrees. So if we update here in degrees now, so see that it will become now 0, and now it will become 1. These two are outgoing edges or incoming edges from the vertex B. Now again see that this is 0, no? So again this is a DAG and it have, in degree vertex which is C. Now let's list out that. Next is G, we will do. So let's remove that, this G. Now this is okay. So let's update now again the in degrees. Okay, this will become now 0, and this will become again 0, and this is 1. So now we have two either we can take A or H, anyone we can take. So let's take here H. Once we take H and we remove, so it will be update in the in degrees. We will update here. So this will become 0 now. This is 0, and any one of again we can write again. So this is A and then D, or anything you want, right? D and A, whatever you want, you can write. So Saurabh have raised hand. Okay. Hello, Saurabh. You are getting doubt with this one? So please unmute, both of you, and let me know your doubt.
Sir, can you explain again how you solve? Means
Okay,
the
I will do it again.
Yes, sir.
Okay. Okay, just a minute. Okay, I will do it again. Okay. So just a minute. Okay. So we'll see it later. Just a minute. Okay. So DAG is what? DAG is a directed acyclic graph. We have a directed graph which don't have any cycle. That's the meaning here, DAG. And whenever you have a DAG, then it have in degree and out degree is there, or whenever a directed graph, you have a in degree and outgoing, incoming and outgoing edges. So here this is outgoing edges. These are the outgoing edges, and these edges are actually incoming edges for these vertices, and outgoing edges for this vertex, for this vertex. Okay, so to start that algorithm, okay, am I audible?
Yes, sir. You are audible. Yes.
Yes,
So
sir.
to start that,
Sir, can you explain out degree once again?
So out degrees means number of outgoing edges. So here is how many outgoing edges are here? How many edges are outgoing edges? 3, right? 3, sir. So that means out degree is 3. Number of outgoing edges are actually count for the out degree, and number of incoming edges for in degree. So here is there any incoming edge for the vertex C? No, right? So that means in degree is 0. For this one, for the vertex A, in degree is what? Number of incoming edges. So there are 3 incoming edges for the vertex A. That means here in degree is 3. Out degree, number of outgoing edges. So there is no outgoing edge. That means out degree is 0 here. For this vertex, number of incoming edges means in degree is 3. Number of incoming edges. Number of outgoing edges are with this vertex is 2. So in degree is 3, out degree is 2 for the vertex B. Similarly, we can count for other vertices. Is that clear now?
Yes, sir.
Okay. Now, for this algorithm, whatever we are doing, we only concern with the in degree. We are not concerning out degree. Okay, in degree is enough to proceed with this algorithm. So first thing, let's count first the in degrees here. So in degree of this vertex is 0. In degree of this vertex is 3. In degree of this vertex is 3. What is in degree of this vertex?
0.
0. There is no incoming edge. Every edge which is related or which adjoined with this vertex C is outgoing only. So there is no in degree. There is no out degree. In degree is 0 and out degree here we can see 3. So in degree is 0 for this vertex. For this one is 3. What is in degree of this edge?
Two, sir.
2. Two edges are actually incoming edges. And for this one is 2. So we listed all in degrees of, so for this one, in degrees 1. So we only concern with the in degrees. Okay. So we listed all here, the in degrees here. Okay. Now we'll proceed with the vertex which have in degrees 0. Okay. So previously I started with E, no? So I will now here start with C. Okay. Because this have in degree also 0. So which have in degree is 0, we will start from there. We will start sorting from there. So first thing I started from C. Okay, in degree of this one is 0. Now we have done this. I have just listed here. Okay, so I will start. Now I will remove this vertex. So once I remove this vertex, means I have to remove the outgoing edges, whatever related to is this vertex. And we'll do the update here. Okay, so let's do the update after removing these edges. So it will become what? From 2 it will become 1. Okay. From 2 it will become 1. And this is from 2 it will become 1. And this is from 3 it will become 2. 1 edges is removed from this. And also from 3 it will become 2. In degrees 2 now. Okay, I removed C. Now which have the in degree? Now again, if after removing a vertex, you will always get a DAG. So here is again we got after removing this vertex C, I got a DAG which have E have the vertex in degrees 0. Okay. So let's list out here E. The next is E. Okay. Now let's remove that vertex E. So I remove this vertex E now. So I will remove the outgoing edges which is adjacent with the adjoined with the vertex.
Sir, just to check the starting and the ending point.
Sorry, starting and ending point?
Wedge, sir, wedge. The E is 0, E is starting.
Sorry, E is 0. No. What are you saying? Could you repeat, please?
Actually, sir, wedge is started.
Wedge. No, I'm not. No, here for related to this problem you are saying. Also from where we have to start. That is you are saying.
Okay, sir. Sir,
No,
one
what
question.
You are saying, sorry, what you are saying? Could you repeat?
Actually, sir, wages started wages this diagram.
Wages.
Actually, he is trying to say ages, but he speak wages
Oh,
for age.
sorry. So this is ages, yeah. Sorry, these are actually ages, not wages. These are the ages.
Okay.
Okay, so once you choose, you choose that vertex which have in degree 0. We will remove that, as here we removed for this vertex. Okay, and then we remove the outgoing edge which is related to that vertex, from where the outgoing is there, that vertex. That's why I am removing. No, if you see that, what I am removing. So this in degrees here is 0. Here is in degree 0. Okay. In degree of this vertex is 0. Okay, as here there is no incoming edge. See that there is no incoming edge, only the outgoing edge is there. So in degree of this one is 0. Now we have sorted here. Now we will start removing the outgoing edges which are related to this one. So outgoing edges is this one, and this one. So we will remove these 3 edges with this vertex also. So we remove this vertex, that means we have to remove this edge, and this one. And also after removing this vertex, we need to update. Now you have removed that vertex. Now you have to update the in degrees, or means here is you have to update the in degrees of remaining vertex. So here is, all of you please mute yourself. Okay. So here it's, let's update here. So this will come from 3. Previously it were 3. Now see that only 2 incoming edges there. So in degree is 2 now. And for this one, in degree is now, this one is removed. Now from 2, only now this is the only incoming edge. So this will be update here 1. Okay. And there is no, now for this vertex F, there is no in degree. So from 1 it will become 0. Now see that, now in degree of F is 0, we will start. So we will list here F, and we will remove the vertex F because it have now 0 in degree. So outgoing edges with F is this one and this one. And let's update the in degrees. So in degree is now of this B. See that this B vertex B in degree is now what? Anyone? What is the in degree of now of B?
0, sir.
Now it is 0. After removing these edges, now it will become 0. And what is the in degree of F? Sorry, this D?
0.
No, is this
1.
0? This is 1, right? This is 1 in degrees there from H. And what is the in degree of, so this have in degree already 2. So this is, now see that B have in degree is 0. So we will list out here B. And now let's remove that B. Okay, so let's remove that B here. So outgoing edges are this one, okay, and this one, these 2. And let's update the in degrees also. So what is the in degree now of A?
A is 1, G is 0,
G
and
is 0, and rest all is fine. Okay, so
1.
okay, this is 1 and this is 1. Now let's, G have in degree 0. So let's list out G here, and now remove vertex G. Once we remove that, the edges is, outgoing edges related to G's will be removed. So this one is removed. This one is removed. Now update the in degrees also. So update will be here. It will become A have 0 now. H will become 0 now. D is, there is no update in D for the D. Now any one of we can take. So let's take A. So if you remove A now, so in degree of A is 0. So if we remove A, okay, so there is no effect as there is no outgoing H. So the next step is H, which have in degree is 0. Okay, so now let's list out H. So in degree is 0. Now remove that. So we remove outgoing H. Now D have 0. So now D have 0. So list out that G. So now D will be listed here, now removed. And this is the order of sorting the vertex here. So this is one order. See that there is this is a different topological sorting. You see that?
In that kind of examples, there are too many orders.
Yes.
Yes.
Topological size. So this is one sorting. This is another one.
Yes, sir. Many orders are there.
Yes, many order. Either it could previously see we have seen A and then H remove. Either it could remove H then A. Similarly, it will be swapped. So there is no issue. Which have in degree 0, we will start removing with that. Once you remove the updated in degree, we will write that and then we will remove that vertex which have in degree 0 and proceed with that. So in whatever you are order the writing, whatever in which order you are removing and that vertex, just write here, and that is going to be so here is a topological sorting. This is a topological sorting. So that means if any person want to do the course, okay, with these courses, so in this order he can do. Either first he can do F, then E, then F, B, G, A. These courses he can do, or he can complete first E, then F, then C, B, G. In this order he can do. So this is a topological sorting.
Shubham sir, I have a doubt in week 9. Can you take that?
Yes.
Sir, can you please also explain the Riemann sum once?
Yes, sir.
Okay, we'll explain that. So is this clear now, Tag? This is one important topic, okay? This is one important topic.
Shubham sir, one question doubt
Yes.
actually exam related question wrong the answer, sir.
Yeah, I have noted too. So is there any another one? Which problem you are saying?
Yes, sir. I have shared the question link and chat box, sir. Question number 16.
In reattempt.
Yes.
Which page?
Question number 16, sir. Mathematics. 16.
16. Okay, 16 is there.
Question number, sir.
Question number 5, 7.
Yeah, this
11.
No, 16, sir. Yes.
15 and this one.
Cartesian related question. Yes, sir. Yes. This 16 question. 3 marks. How many pupils like all 3 movie? This is the answer is a 75 correct, but is randomly put the 6. So actually, this question is a previous qualifier question. Question is a 75. Correct answer. You have the solve question is answer correct. 75. Actually, solve the question is correct.
No. So here is this. What is this? So what is in this problem? Like it is asking all three, not even no. It is asking for all three.
Yes, sir. Yes, sir. All three. Actually, this question is a previous repeated question. According as per the same question, correct answer 75, and the solution I have solved the question, and the final answer this is 75, because it's a 5% is a none of these generic, and the 100% 100 minus 5 95, and total is the 3, and minus the both. Subtracts and the Cartesian formula use, and the 80 95 minus 80, this is a 15%, and the 15% divided by 15 upon divided by 100 multiply total of the 500, and the cancel 75 is a correct answer, but randomly he is the put is 6.
Okay.
Actually this question is a week 1 to week 4 mock question, as per as same question. You have solution is available.
Oh, sorry. Okay.
I have put the send feedback, but not sure.
This is of one of the mock.
Yes, sir. Mock question.
Okay, just a minute. Let me see it. Which mock is this?
Week 1 to week 4. Solution, sir, is there available as per the same question.
Okay, no issues. This is of mock week 1. Where is the mock?
Week 1 to 4. Solutions.
So how many student?
Solution is available, sir. Please check the solution.
Okay.
So this question is, I think, this question repeated question. 2023 February question. 75. You correct. Yeah, this 25% upon 100. This is a, this question is a 500 people. This is the 1,000. And
So this is on the 1,000, no? So this is for the 1,000.
Yes, this is the 500, and the calculate the how many people like all the three subject. This is the all the three subjects.
So how many students like all three subjects?
Yes, yes. Actually,
sir, but sir, the question is changed.
Yes,
Not
that's what
question
I'm saying. So that is what I am saying. Maybe okay.
No, sir.
Okay,
No change question. Question no change, sir. Actually, I have.
No, this is 1,000. No, this is here is 1,000.
Yes,
But here
yes, sir. Data is a change, but data is a change. Question is the same. This is the 500 people, sir. 500 people, and subtracts total 500, sir, and 15 upon 100
so
multiply
see that
the
here is
500.
also something here is 500 people, and also 49 is liking here or watching comedy movie. But here
Yes.
is the showing that no, here is
data is a different, sir, but question process is the same, and I have same process solve. And previous term question,
He
sir.
is trying to say the concept.
Concepts are fine. I'm getting what he mean to say. I'm getting that. So okay, so you are saying this have the wrong answer, okay?
Yes,
you are
sir.
saying.
Yes, sir. Actually, 75 is a correct. Previous year term question, sir. This term is a correct question. 75 is a put there. This qualifier is a 6. I have checked the question.
Okay, I will check it. I will check this. And
If you solve that question, he will satisfy.
Yes,
He
sir.
will.
Yes,
Sir, he is right.
Yes, sir.
Sorry.
Sir, he is right.
If you solve that question, he will
He
satisfy.
also shared this question yesterday. I solved it. I got 75 answers.
Yes, 75 is a correct answer, but 6 randomly is the put.
Okay, no issues. If it is 75, okay, I will check it. Okay, thanks for here. I will just make a note. Okay, I am just making note of this. The answer is okay. We'll
Answer
check
is
with the
a
answer. This
answer is a
time,
75. 75, sir.
okay, I'm just making note. This is of, okay, 5.
Actually, all question repeated questions, sir. Only for one question
Okay,
not
so
there, and all question repeated.
student,
Sir, in quiz 2, the questions are 64 and 71.
yes. Okay, I'm just making note. Okay, I have noted this one. Okay, we will check these 3 problems. Okay, of the reattempt 1 and from our quiz 2. Okay, we'll let you know with the announcement. Okay, don't worry.
This question is a wrong answer, sir.
So can I conclude one thing only, sir, for the quiz 2
So
question
if it
number
is
17?
wrong, no, if it is 6 is given, okay,
54.
don't worry. If it is 6 is given, no, so
Yes,
probably
6.
it will be like it is a NAT, no, so who will keep the 75 will given the marks, okay, so don't worry, it is not option wise, it is a NAT, no. So
sir, mark is
who will
a evaluation, no, sir?
Yeah, so who
75
will
is
give the, I think in the this PDF have some issue, okay, we have given actually the correct one, whatever you were saying, but this PDF have some issue, okay, of this TCF format. So
PDF
we'll
is
check. That's
issue.
why I'm saying I'm not saying anything here that we are not giving surety that we will check, okay, and who
sir,
will the correct
5,
with this one will
sir,
give the mark.
Shubham, sir, 5 minutes stamps and solve the question, sir.
Don't worry, I okay, later this topic, so let's finish first, okay, so don't worry, if it is 75 then it is the answer will be 75, so why you are worrying?
Yes, sir, 75 is a correct answer.
Okay, so don't worry.
Excuse me, sir. Sir, actually, I just want to conclude one thing, sir. I'm just asking, like, it's not a type of thing, but like in the question in the quiz 2, question number 64, where fx is 1 by x minus 1. So we are finding the discontinuity at x equal to 1 and 2. I'm just asking that if it is a rational function f of x, the rational function, then the rational function is always continuous in its domain, sir. So in all the 4 options, it is written that where it is discontinuous, like in all the 4 options. So every rational function is continuous in its domain. So at x equal to 1 and x equal to 2, the function is discontinuous. That is what I think, sir. But it's okay. We can check for this question only.
Okay,
But they have asked for the domain.
Let us. Okay.
Where in the domain it is
Okay, let's
discontinuous.
check. So don't find, okay, we know that there is a issue or there is a ambiguity. Okay, don't worry. I also know that there is already know that there is ambiguity in that. So don't worry. We'll with the team. I will check and we'll send an announcement. What will be the final thing? Okay, don't worry.
Okay, sir. So try to
this,
give
this
marks
for this problem, the answer is
75, sir.
this problem, it is, see, the issue in this PDF only. Okay, the issue is in this PDF only. Otherwise,
But
the
sir,
answer, whatever you are
Shubham,
saying,
sir, second number answer is a correct, 17 correct and 18 correct, but first option is a 6 randomly one. 75
So
is
so let me complete it. This is the answer of this problem is, I am also seen that I am in my PDF. I just now seen that the answer is 75 in this PDF. Whatever this TCS format PDF is this PDF have issue. This here it is not 6. This is randomly in this PDF have kept, but in whatever we have created, the answer is 75. Okay, so don't worry. In this PDF is wrong, but it will be. It is answer is 25. I have checked now. Okay, just now
sir.
I checked.
Thank you, sir. Thank you, sir. Thank you very much, sir.
So I have a doubt. Can you take that doubt, week 9?
Yes. So now let's move to our topic. Okay. So this is all about, I think, of week 10. The only DAG, DAG is Riemann and topological sorting, which I now discuss. And let's be kind of open and please let me your doubt. Okay, we'll discuss that doubt, and I have just noted these 3 questions also. Okay, don't worry, we'll discuss. Okay, I will discuss with the team, and We'll send an announcement regarding this, surely.
Sir, can you explain VFS and DFS once again?
Sir,
Okay.
also can you please explain Riemann sum?
Sorry, what?
Sir, the Riemann sum.
Random sum.
Sir, from week 9, the Riemann sum.
Sorry. Okay, yeah, sorry. Yeah. Oh yeah, that is generally Riemann sum. That is
Okay,
called
sir.
Riemann.
So I wasn't sure about the pronunciation.
Okay. That is or
Sir,
maybe
9.3.
which problem?
Sir, second question.
Hmm?
Actually, I tried that question to solve, and I little bit solve that question, but I'm not able to find that height. But when I tried to reverse all that question, the answer is correct. But mm, but from
So,
straight, I can't find how the height.
so the height is then option wise. If it is not able to get, then option wise need to go. Here is the parallelogram is given and theta is given 60 degree. Perimeter is given 10. Okay. Then which of the following height is going to be saying to be this one? Area of parallelogram is this one. So if this angle is given, then this is a parallelogram.
In parallelogram, the sides are equal.
Sides
So
are
the,
equal. No.
yeah,
Sides are the parallel. Sides are parallel, no. And this is 3. All sides are actually 3. No. So
Opposites are equal, sir.
Opposite sides are only the equal. Means if it is 3, then this one is 3. If it is 4, then this one is 4.
Yes, sir.
This is the meaning of.
Yes.
And what is the formula to find the area of a parallelogram?
Base into height.
Base into height only, right? There is nothing more. Base into height. So base is here is not given. So here is, that's why the perimeter, no? Perimeter is given. So and this one side is given, you need to find the another side. So that means here, if it is 3, if this is given and this height is given, so area of parallelogram is this base and this height. So let's say this is A, B, C, D, and this is 3 is given, and perimeter is given. This perimeter whole thing is given, which is 10, is given in that problem. And if this one is 3, then this one is going to be 3. We need to find this one. We have to find this one. So what is now the formula of perimeter of the parallelogram? It is exactly similar to rectangle. So that means here 3 and 3, 6 it will be. And if it is x is this one, then this is also x. So this is 2x. This 10 is given, perimeter 10. That means 2x is equal to 4. That means x is equal to 2. That means here, if it is x here, we assume here, so this is 2. Now we got the base. And this angle is given 60 degree, right? So we can use to find the height, right? This is a right angle triangle. And now we can use tan theta, or what is the cos theta? Cos theta is equal to so, or not 3, not cos theta. Here is, if it is this one is 3, then sin theta we will use. So what is the sin theta?
60.
This height upon 3. And the sin 60 is what? Sin 60 is root 3 by 2. And this is h upon 3. That means finally h is equal to 3 root 3 by 2.
Sir, can you repeat? Yes.
So yeah, let me make a bigger picture here.
Sin theta बराबर h बट्टे b.
So here this angle is given 60. This height we want, and this side is given in a parallelogram. Okay, in parallelogram, this is equal to this one. That means this is 3. This is equal to this side. So if it is x, then this is also x, and perimeter is given, right, which is 10. That means this x plus this 3 plus this x and this 3, right? This is equal to 10. That means here 2x is equal to 4, and x is equal to 2. That means we got 2 here. So it is finding of the area. It will help to find the area, but we want to find the height. So now this is a right angle triangle, right?
Yes, sir.
This is a right angle triangle, and this is hypotenuse, right? This one is, and this is height, this is base, and this is hypotenuse. So we can use now sin 60 equal to height and this 3, right?
Yes.
And sin 60 is 3 by 2. And this now h we can get 3 upon 3 by 2. Similarly, now base is already we got. So area equal to 2 into height. Base into height. Height is 3 root 3 upon 2, which is 3 root 3.
Okay, sir. Thank you.
Now, Riemann sum.
Sir, there is one more doubt in same activity. Can you scroll down that activity?
Okay. Which activity?
Sir, scroll down, please. Scroll down, sir. Yes, sir. 9th question and 10th question.
9th and
10th. 10th answer is I know, but 9th.
So in 9th, what is the issue in this problem?
Sir, actually,
what is your doubt?
There is circle, and in that circle the square is given, and in that square also.
No, this is not a square is given. It is just a radius. R is given. Okay, radius is given, which is in a sequence wise, means a kind of sequence, and it is a increasing. Radius of a circle is increasing, so areas of the circle is also increased, right? Means here the problem is saying you have a circle, okay, or suppose you have a circle and each time radius is increasing, means circle is increasing, that means area is increasing. That's the meaning here.
Yes.
This is R1, then this is R2, this is R3, this is R4. Okay, this is the meaning of this problem. This Rn is given as here. This is a so this is R1, some radius will be, you will get some R2 different radius. So this is a collection of circles, and the radius of each circle is given here. Okay, and what is, so for example, n equal to 1, the radius will be already given. For C1 is 1 by 4, for C2 is this one. So area will be, then the area will be this one. So whatever the thing is there, the next problem is the area of the biggest circle is less than 5. Area of the biggest circle is greater than pi, less than pi. Area of the smallest circle is this one. Area of the smallest circle is pi. So what is going to be the, now it is increasing. So what is going to be the smallest area, smallest circle, area of the smallest circle? What is going to be the biggest area?
Inner one. The inner
inner
one.
one, the outer one, where it will like, where it, the hint is also given, find the limit, where find the limit, and that is going to be, it as it is increasing, so it will converge to the maximum limit, right? Sorry, maximum, as it is increasing, and you find the limit, so it will converge to where it have the maximum number, right?
Yes, sir.
As the sequence is increasing, so it will be at the maximum point. That is going to be your biggest circle. And
Yes.
as the circle is giving as a kind of infinite, it is continuously increasing sequence kind of thing. So it will converge to a circle where it have the largest, or even it will converge to a circle which have, it will convert the Rn, sequence R1 will convert some number. That means your circle have radius, the biggest circle have radius less than that number, right? That's the meaning here. And that's why the area now pi r square. You'll use that, and that this is going to be lesser than pi with that number where it is converging. So think it again. Okay, I'm just giving a hint. If you read out that problem, you'll get that. Okay, just read out that again, problem. See it again.
Okay.
Are you getting now?
Yes, yes.
So let's discuss the Riemann sum. So Riemann sum is so there are three type of Riemann sum. I have spent much time on Riemann, so okay. My suggestion is, okay, what is the Riemann sum is that first thing, it is a given, you'll get a function. Let's say you have a function 3x plus 5. Okay. And the problem is that find the Riemann sum of this one in the interval 1 to 5. Okay. After dividing this interval into 4 equal steps, into equal intervals, or even it could be written as equal interval, into dividing it equal interval. That means suppose here is this within this interval, this is 1 here, this is 5 in this interval. So equal interval means what? If you divide, so if my suggestion is, please go through where we were discussing. I will just quickly do a problem, and then maybe you will get that. So here is 4 equal interval means if you divide this interval into 4 equal.
Sorry to interrupt you, sir. Where were you discussing Riemann sum? Sir, was it?
So I took very long time to discuss. I spent much time there. Okay, let me just 1 minute. So, if it is of any one of the session, like on Friday and on Sunday, I think this is week 10. Sorry, this is Friday, no? This Friday, week 8.
ना sir,
but it is showing only the TA session.
Yes.
Where is this session?
Sir, actually, I was trying to look for the video on Riemann
sorry, this
session.
is on the on the Saturday. It is shifted on Saturday. So of week 9. This is on of week 9. So we discussed there on Riemann also. So we discussed of, yeah. So this is the Riemann. See, I spent at least 1 hour, I think, on this, and slowly explain that what is how you are dividing that, what is and okay. Still here, see that more than 1 hour. even it is more than 1 hour we discuss. See that. Yeah, we are still discussing on the Riemann. And also I did a problem on that. What is a partition? First thing I started with what is a partition. Okay. Then after discussing partition, how we are like what is the norm of a partition? Okay, slowly we have discussed what is the norm of the partition, and then after how to find the Riemann sum, what is the left Riemann sum, what is the right Riemann sum, and so that each steps. Everything
Yes,
I
sir.
have
Actually, I
discussed, I
was
think.
trying to
Once you
find the
watch
video.
that,
I
then
wasn't
there is
able to find it. So now I'll watch this one. Okay. Thank you, sir.
yeah. So this session is from Saturday. It is actually shifted to sorry, Friday. It is shifted to Sunday. In that morning session, we have discussed.
Okay, sir.
Sir, 25 November, na
Sorry?
sir?
This is on 25 November.
Okay,
This
okay.
is okay. Okay. Anyone else have doubt? Okay. Atharu have raised hand. Hello, Atharu. What is your doubt?
No, sir. My doubt is clear.
Okay. Disha? Yeah. Hello, Disha.
Hi, sir. Sir, my doubt in BFS and DFS, can you explain once again?
Okay. Okay. So BFS and DFS. That graph, let me take a graph, any graph I can. Okay, let me take that any graph. Let's take from practice. Okay, this is a graph. Let's check this problem. And this is not on the BFS and DFS. It is from independent. So BFS and DFS could be done on any graph. Okay, so it could be done on even directed graph also. We can take any. I took for the undirected graph. We can discuss even the directed graph also, like this one.
Okay, sir.
So any one of the, like either it could be directed or undirected, we can discuss, or the DFS and BFS could be done. Okay, so for BFS and DFS, to start the for both BFS and DFS, we have to we have to take a in starting. So suppose this is 1, this is 2, this is 3, this is 4, this is 5, 6, 7, 8. So these are the vertices we have. So let's start the BFS from this vertex 1. So I will not write the Q here. Okay, I will just explain from the graph. That Q is not needed. Okay. Suppose I started from 1. Okay. So I started from 1. So what is that? So I started the BFS breadth first search from 1. And then what are the vertices I can visit? I can visit the vertex 2 here and vertex 3 here, right? These are actually adjacents. And also I can visit this vertex 4, and because this is one edge connected with 1, and I can also visit vertex 7 right here. So this vertex, this 4 vertex I can visit from only vertex 1. So this is a kind of you are on a you are on a pillar or something, on something, you are stand there and you have telescope or something, whatever something you have in mind, and you can visit, you are looking some other places. So that means this is the way you can visit this place from your place. You can visit these places because these have the edges. That's the meaning here. So that means this is the meaning of the visit. You can visit vertex 2. You can visit vertex 4, this vertex, and you can directly visit 7 here, and you can visit 3. That means here, if you have this vertex 1, so okay, so I can visit 2, I can visit 4, so this is 2, this is 4, I can visit 3, and also I can visit 7. Okay, now once you visit, so level wise, if you note the level, that would be good. So if it is started from 1, so that means it have level 0, and now whatever I can visit the vertices that have level 1, 0 plus 1, which is 1. So these 3 vertices have level 1. Why I am making the label? Because I am not making Q, that's why I am making a label. Okay, because it will be make me a remind that after doing this one, which vertex I will do to explore that. Like suppose I visited this vertex, now I will start exploring. So let's start the exploring 2. Okay, so I explored 2, I started exploring 2, so I just reach to vertex 2. Now after reaching 2, I start visiting from 2. So I can visit from 2, I can visit 6, this vertex, and I can visit 1. So 1 is already visited, I already done, which helps. From 1 we have seen 2, so it is already done. So that means I can visit from 2, I can visit vertex 6. Okay, so what is going to be level of this one? Level of this one is going to be, this have 1 and 1 level is added. So that means this have level 2. Why I am making this level? After this one you will get that why I am making this level. So this have level 2. Now what is happening? Now I will not start watching from 6. I'm not explore. I visit this one. I'm not going to explore 6. I have to go the level, whatever the level of equal level, I will do that. Means now I will go to either go to 4, I can go to 3, or either will go to 7, because these have the same level. So I started from 1 and reaches to 2, and then once I done with the 2 exploring 2, I can visit 6. But from now I will not move 6. I will back to here with the same level. I can go 4. So let's go to the level 4 now, because it have let's go to the vertex 4, which have level 1. Means at the same level, what I have the same level, we will visit first those, then I will go to the next level. So that's why let's start visiting, start exploring 4. So from 4, I can visit 6, right? From 4, I can visit 6, I can visit 5, and I can visit 1. So 1 and 6 already done, right? These 2 have already done. Only 5 is new. So I just visited here 5 now. So what is the level of 5 is? Of this, whatever the level of this one, added 1. So that means 1 plus 1, which is 2. So level of 5 is 2. Similarly, of level here is already 2. We have this note here. Now this have level 2. Now no other vertex I can visit. So I just kept in mind. Now which one start exploring? Now which vertex I can do is I need to explore 6 or 5 or other, or which vertex will do the exploration?
5, sir.
Why 5? That's why I am just making the level. No, this have level 2, but we have to first finish the level 1, then we will reach to level 2, right?
Yes, sir.
So that's why I'm making the label now. Here is that's why I said no, I will make the label, and for the understanding which have that, the understanding is that we have to first finish level 1 and then the level 2. So let's finish first, because from 2 I can visit 2, 2 from, from 1 I visited 2, 1 and 4, and then from this one 2, then 4, this 3, and this 7. So these are remain, no? This 3 is remain, 5, 7 is remain. This have label 1. So let's finish first these labels, this 3 and 7 vertex. So let's start visiting 3. Even 7 we can do. Let's start visiting 3. So from 3, I can visit 8, I can visit 5, I can visit 6. So from 3, 6 is already visited. No, from 3, this is already visited from 2, 5 already visited from 4. Only the new thing is 8. Vertex 8. So what is the level going to be level of vertex 8? Previous level of, and then added 1 plus, and then add 1. What is this one, and then add 1? So this is going to be level 2. Okay, our exploration of the 3 is done now. Now which vertex we will do explore now?
4.
4 is already done, no?
Okay. 7.
Now 7. The 7 levels, vertex 7 have level 1. So these are, that's why here the queue meaning is either I can make a queue and then from there we can do, or here is I'm making record that label. This is the meaning. So here is 1. So sorry, 7. 7 is remain now of level 1. So let's do the 7. 7 is what? 7 is I can visit 8, I can visit 5, I can visit 1, I can visit 6. And these all vertices are already visited with the others, whatever we did. So there is no, once we started exploring 7, there is no need to move ahead as all our vertices have already visited. Okay. Now we will go to the level, second level. And in the second level, here we have 6 is there. Okay, 6. So we'll start exploring 6. Level 2, and started exploring 6 now. So 6, whatever we will see already visited, no? From 6 we can see 2, 4, 3, 7. And these all already visited. We have visited 3. So that's why it will be removed from queue. That means this is done. And now 5. Again, if we do start 5 is here. These all other vertices are actually visited from 5 also. There is nothing remain. Then we are done. And then 8. And then 8 is already, if we do a start exploring 8, this is already done. 3, 5 already done. Sorry, 3, 7 already done. So this is the mean. So either you can remove. So what is so this is the BFS tree we got. This is your BFS tree. So from 1, this 2, this 4 is there, this 3 is there, this 7 is there. And then from 2, I visited 6. And from 3, I got 8. So this is the BFS tree of this graph. This is a BFS tree. There could be different BFS tree also. It's depend on, no? I started from 1, I reaches to 2. It could be from 1, after 1, I can start from 6. Then the BFS tree will be what? This one. Or we can from 7 I can do, because these all have the same label. So this will be another BFS tree. Or from 3, no, from 3 we cannot. From 3 also we can do, because there is a direct edge here. So from 3 we can. So this is a BFS tree. So there are so many BFS tree with the for one graph. There are so many. What I am doing here, is that clear?
Yes, sir.
Okay. Now, what is the DFS? So here is again 1, 2, 3, 4, 5, 6, 7, 8. So what is DFS? DFS is exactly exactly searching on internet. I started from 1. Okay. I started 1. So I can go 2, I can go 4, 7, 3. So let's move to 3, any one of, because there is one edge. So I can go anywhere. I can go 2, 3. Well, so let's go 3 here. So I can, from 1, I went 3. I went 3. So from 3, I can visit 5, 8, 6. Right. So any one of the place we can go. Let's go to 3. I can visit 3, right? So I visited 3, so let's explore. Sorry, from 3 I visited 8. So let's reach out to 8 and start exploring. So from 8 we just reaches to 8. So from 8 I can visit 7, and I can visit 3, which is already visited. So let's move to 7 now. So from 7 I can visit 5, I can visit 6, any one of them. So let's move to 5. Okay. So once I move to 5, and from 5 I can visit 3, which is already visited. So there is no need to go there. I can visit 4. Yes. So let's move to 4. And from 4, I can visit 1 or 6. So 1 is already done. This one is already done. So from 4, let's move on to 6. So from 6, I can visit 7 or I can visit 2. So 7 is already visited. Let's move to the 2. So from 2, when we reaches to 2 here, and from 2, I can visit 1, I can visit 6. So already 1 and 6 already visited. So let's backtrack here. So then backtrack. So from 2, I reaches to 6. So again, from 6, there is no remaining vertex which have visited. So because already 6 is already visited, 4 is already visited, 3 is already visited. So let's back to 4, then similarly back to 5, similarly back to 7. There is no new vertex. Everything is already explored previously. So back to 1. So what is the BFS tree? Exactly on 1, no? 1, 3, 8, 7, 5, 4, 6, 2. By this way you can write, or like this you can write, whatever the way you can write. This is only.
Okay, sir.
Okay. Okay, this is all about for today.
Sir, DFF means distribute file system.
No. DFS means
distribute file system.
No. Depth. No, distribute.
Actually,
not depth.
actually,
This is
sir,
for
data
depth.
related, I think.
No, not depth. The name is depth. First search. BFS meant breadth first search. Already in the name is given, no? The name is given here.
But sir, Google search and the name is data according to systematic.
No. So here is not, that is a Google search. Yes. Google can list of many words, no? But here is our purpose for DFS mean depth first search, and BFS is breadth first search. Okay.
Okay, sir.
Okay, this is all about today's session, and don't worry with the quizzes, okay? And that's that PDF, no, the TCS format have some issue, because I have already given the correct answer 75, but I'm looking that in PDF it is showing 6. That is the issue in the TCS format, but 75 is the correct answer. So don't worry.
Okay, sir.
And for our quiz 2, there is that problem of the continuity problem has some issue. That new problem also I got of the domain thing. So these three problem. So already one sorted. Remaining the quiz 2 problem, we'll see it and reflect to you with the announcement.
Actually, sir, check the paper of IT Madras, TCS.
No, so whatever the TCS is given, that is only.
Oh, TCS check the paper.
Okay.
Shubham, I had one general question. you are writing on this notepad, right? What device you are using?
This is OneNote.
OneNote, and you have you are working on a Samsung pad, is it? Or
no, this is generally this is Lenovo Legion, not Samsung. Laptop. This is a laptop, not a pad.
Oh, okay.
With a writing device.
With the writing, okay, on the screen itself you are writing. Okay.
Not a screen. This is one different Wacom. You know, you will use Wacom, and there you can write.
Wacom. That's a separate device, right? Which
Yes,
we have to
separate
connect it
device.
to the laptop.
Yes, with the cable.
Oh, okay.
Okay.
Sir, for that quiz 2 question, please give marks for our students, sir.
Okay, we'll concern. Maybe, yeah. Okay.
Okay, sir. Okay,
Let's
sir.
see.
Thank you.
Sir,
Yeah.
Okay, thank you.
Yes.
sir, for practice assignment for bonus marks, some of the assignment question are changed every time.
That is kind of randomization. Because of randomization, if you are submitting, then you will get a mock. Sorry, the bonus mark.
Okay, sir.
Okay.
Sir, when will this come, sir?
Sorry.
Yes, sir.
Okay. Thank you so much. Good night to all of you.
Thank you.
Okay,
Good
sir.
night,
Thank
sir.
you, sir.
Good night, sir.
Good night, sir. Thank you.
Thank you, sir.
Thank you. Good night, sir. Bye, sir.
Good night.
Bye,
Good
sir.
night.
Thank you. Good night, sir.